All right, so hey everyone. So again, our aim for today is how do we convert between rectangular and polar coordinates. Here now is an example of like what we did yesterday, right? Just finding different representations of the same point. Okay, so using what we learned in the previous lesson and using the rules below, so A through D, write 4 different representations of this point, 3 comma 5 pi over 4. All right, so let me get to the solution for that. So same thing that we did yesterday. First thing we're going to do is we're going to add 2 pi to this angle to get a positive radius value and a positive angle value. So just, yeah, again, add 2 pi to theta. For part B, we had to have theta be negative. So instead of adding 2 pi, we subtract 2 pi. And let me change this notation. For part C, we had this should be, yeah, sorry, negative radius and positive angle. So we negate the r value, so 3 becomes negative 3, and then we add pi to the angle, so we get negative 3 and 9 pi over 4. Okay, so pi, you can see that as 4 pi over 4, right, since we're adding fractions. So we get 9 pi over 4 for the angle. Okay, so again, negate r, add pi. For part D, we're going to negate r, and we're actually going to add negative 3 pi. So yeah, add negative 3 pi or subtract 3 pi to the angle because as I explained here, subtracting pi would still leave theta being positive, which is why we have to subtract the next option, which is 3 pi. Okay. So yeah, it's going to be negative 3 here, and then 5 pi over 4 minus 3 pi. 3 pi, you can see that as 12 pi over 4, and you're going to get negative 7 pi over 4, right? So again, just to check, if you subtract pi, then you're going to get 5 pi over 4 minus 4 pi over 4, which is positive pi over 4. But again, we need a negative angle here. So yeah, that's why we have to subtract the next option, which is 3 pi. Okay. All right, yeah, I'll leave the solution up here for you to copy. Oh, yes, question?
Would it always say when to make a positive angle or a negative angle?
Not always, right? Because like, the questions yesterday, they just said to, yeah, they just said two options with positive radius and 2 options with negative radius. So yeah, they won't always specify like this, but you can see like questions like there is on the class or the homework, right? All right. Does anyone still need to copy this? Okay, I'm gonna move on then to the slides. Okay, so again, we're gonna talk about how to convert between rectangular and polar coordinates. And to do that, we're gonna just work with this diagram at first. Okay, so yeah, I know it says your partner, but that's if we were in class, I would have you work together. But for the sake of time, I'll just go through this. Referring to the diagram, take a few minutes to sit with your partner and come up with equations involving x, y, r, and theta. So here you have a right triangle, you have a polar coordinate here. And I know this is a rectangular axis, so like x and y, but there's like r and theta, so is actually like a polar coordinate on the Cartesian plane. Okay, and I want you to come up with equations involving x, y, r, and theta. All right, so think about like actually the classwork yesterday, the first question, we had the Pythagorean theorem, and we also had another formula, which I'll leave to you to think about relating these. Okay, so take like 30 seconds, think about which formulas can relate these four parameters. All right, so at this point, feel free to type your responses in the chat, or you can speak up. So which equations involve x, y, r, and theta? Yes, Ahad.
Actually, I just got an equation using x, y, and r, supposed to include theta in it, but what I wrote was r equals the square root of x squared plus y squared. That's what I got so far.
R is the square root of x squared plus y squared?
Yeah.
Okay, yeah, very nice. Yeah. We're actually gonna add a plus or minus in there because I know like normally we don't do that because Pythagorean theorem talks about triangles and lengths, so that can't be negative, but with polar coordinates, we've seen that r can be negative. Okay, so just add a plus minus there. But yeah, very nice. That's the first formula. And anyone come up with a formula involving theta?
X divided by cosine theta.
One more time.
X divided by cosine theta.
X divided by cosine theta is,
Should be
what
equal
would
to
that
R.
be?
Should be equal to R.
Okay, good. Yes. Yeah, we're going to see another form of that. It's going to be r cosine theta is x. Good. Very nice. And then one last formula involving sine theta. What would that be? So what is sine theta equal to in this triangle?
Y over R.
Y over r. Good, right? And then we're gonna just like Ryan's formula, right? We had we're gonna cross multiply. We get y equals r sine theta. And Ryan, am I saying your name correctly? Is it? Do I say it like Ryan or Ryan?
You can say Rayon.
Ryan.
Ryan.
Okay. Sorry. Yeah. As Ryan said, it's going to be r cosine theta. Right. Okay. So let me get to the derivations for that. Yeah. So yeah, actually, I just wrote it up here. As you said, right, sine theta equals y over r, cosine theta is x over r. You don't have to copy this down just yet. I'll tell you when. And then we're going to cross multiply. We get y equals r sine theta, x equals r cosine theta, right? So we're going to use this, right? So on the left, we have rectangular coordinates, right? Rectangular being like x, y. And on the right, we have polar coordinates, which is r and theta. And then for the other equation, as Ahad said, right, it's x squared plus y squared is r squared, and then we take the square root of both sides. Just make sure you add in a plus minus there. And we also can add in another formula, which we did not talk about yet, which is tan theta equals y over x. We saw it yesterday in the first problem in the classwork, but yeah, you can use that to go from rectangular to polar. Okay. All right, let me go to the slide for you to copy. So yeah, these are the formulas that we see here. Can someone read the first part?
In summary, you can go, Leo.
To convert from polar to rectangular coordinates, use the following: x equals r cosine theta, y equals r sine theta.
All right, very nice, thank you. So yeah, from polar to rectangular, right? So if we want rectangular coordinates, then we want to isolate the rectangular coordinates. So we would just want x and y. And then, you can read the second part.
To convert from rectangular to polar coordinates, use the following: r squared equals x squared plus y squared, and tan theta equals y for x. And choose r and theta so they give you a point in the same quadrant that we're gonna point this in.
All right, thank you for that. So, yeah, the asterisk, the note might not make sense right now, but as you'll see, there's going to be, multiple options, right? Because, it's r squared. So we get plus or minus if we take the square root of both sides. And then for tangent theta, as we've been doing in our trig unit, right, you can see that there's going to be two answers for every theta, every angle, right? Two angles for every ratio here, right? So like, let's say tan theta equals 1, right? Then the angle theta would be pi over 4, that's quadrant 1, and then 5 pi over 4, which is quadrant 3. Okay, so yeah, we can have two options for each of these formulas, right? So that's why we have to choose r and theta so that they give you a point in the same quadrant. So we have to like have an extra step of like matching them together so that they match the original point. Okay, but yeah, we'll see some examples of that today. All right, does anyone still need to copy this? No? Okay, I'm gonna move on then. I believe the next slide is an example. Yeah, just 2 questions and then we're done for the lesson. Okay, so here's our first example. So we're going to convert this polar coordinate point to rectangular coordinates. Okay. So yeah, we're going to use the formula that isolates x and y, right? Because we want rectangular coordinates, so we want x and y. So x equals r cosine theta, as we just saw, right? So that'll be 3 cosine 2 pi over 3. Now cosine 2 pi over 3, that's rectangle 60 degrees, quadrant 2, right? So that's like right here. Okay. So cosine 60 degrees is 1/2, but now it's negative, right? Because we're in quadrant 2. Cosine's negative in quadrant 2, so it'll be negative 1/2. So final answer for that will be 3 times negative 1/2, which is negative 3 over 2. All right, next we have r sine theta, so that'll be 3 sine 2 pi over 3. Same angle here, right? We have 3 times square root of 3 over 2, right? Because sine 60 degrees is root 3 over 2. Sine is positive in quadrant 2, so it'll just be root 3 over 2. Just multiply, you get 3 root 3 over 2. All right, so our final answer here in rectangular coordinates, this polar point is negative 3 over 2, comma, 3 root 3 over 2. All right, that's your first example. And then next example, we'll see how to convert this to polar coordinates. All right, anyone still need the first example here? All right, I'm gonna move on then to the second example. All right, so this one, we have to convert this rectangular point to polar coordinates. And again, from the slide, right, if you remember the asterisk, the note, we had to, there's gonna be two possible answers, right? Or, four possible numbers that we have to match up accordingly. All right, so -7, -7. For these questions, it's always wise to draw the point, right? So you realize like where the original point is in. So it's in quadrant 3, right? So -7, -7, that's quadrant 3. And let me write that here actually. Original point is in quadrant 3. All right, just keep that in mind. When we get our r and theta values, we have to match them up accordingly. All right, first thing we're going to do is find the angle. So you tan theta equals y over x, right? So that'll be -7 over -7. In this case, it doesn't matter. But yeah, we're going to get +1. So theta, the angle is pi over 4 or 5 pi over 4, right? So again, tangent is equal to 1 at pi over 4 and quadrant 3, 5, which is 5 pi over 4. Okay. So those are our two answers. Next, we have to find the r value. So we do plus or minus square root of x squared plus y squared. So plus or minus 49 plus 49, that'll be plus or minus 98. And actually, let me make it even more clear what my math is. So that's square root of 98. And then this is equal to, yeah, I guess you could even see this from the beginning, like 2 times 49, right? But yeah, that'll be, square root of 49 is 7, so we move that to the outside of the radical, so it'll be 7 root 2. Just make sure you have plus or minus. Just to be technical about it, let me add that in, plus minus. All right, so as you see, right, there's two possible r values, plus or minus 7 root 2, right? So it's positive 7 root 2, negative 7 root 2. So the correct matching though, so again, we have to match them. It's going to be negative 7 root 2 pi over 4 and positive 7 root 2 5 pi over 4. Okay, so this answer would not work if it was like negative 7 root 2 5 pi over 4, right? And just for that, all you have to do is just graph it. So as you see in my graph here, right, if you have 7 root 2, then you have to rotate to get to the third quadrant, like to get to this original location, you have to get to 5 pi over 4, right? That's how much you have to rotate by. Okay, so it's 7 root 2, 5 pi over 4. If you had the negative r value, negative 7 root 2, right, you would start on the left and then rotate counterclockwise, pi over 4, that's 45 degrees. That's quadrant 3. Okay, so that's why this is the pairing. Okay, so I have an extra note here, right? Explain why pi over 4 for negative r and 5 pi over 4 for r is the right pairing. Again, it's because the quadrant for -7, -7 is in quadrant 3. Well, actually, because the point is in quadrant 3 and the polar coordinates match that location. Okay, so this is your final answer for this example. Question?
Wait, how'd you find the angle for this?
Yeah, so I just used the tan theta equals y over x formula.
Okay.
That was like the last form on this slide. Right over here. Yeah, this one.
Oh, all right. Thank you.
Yeah, Ahad?
I think I had a hand up from.
Oh, okay. Okay, so yeah, whenever you're converting to polar coordinates, just remember that there's two possible answers. Okay. All right, and that makes sense, right? Because polar coordinates, right? We've seen like different representations, right? Whereas in rectangular coordinates, right, x, y, there's only like one unique point, right? So yeah, -7, that's like the only point that would describe this. Unless you can like, yeah, like you wouldn't have like another numerical value that describes this location. And just as an added note, right, just notice that as we've been doing in those examples, like finding different representations, if you take the negation of +7/2, you get -7/2, and then you can subtract pi, right, to get pi/4. So these are, different representations of the same angle, as we've seen. Okay. Okay, so that's the time we have for today. For closing announcements, we'll continue this lesson tomorrow with the classwork. Remember, there's SGI today, as usual, 2:47. Drop by if you have questions. And yeah, another reminder, I guess, just leave a comment on quiz 4 if you have anything you want me to grade manually. Okay. All right, but yeah, that's it for today. I'll see you all tomorrow. Have a great rest of the day.
Thank you.
Have a good day.
Thank you, Mr. Lane.
Thank you too. You're welcome.